Hello, Alex here, and in this video I want to talk about Kodak Xtol, a two-part powder developer for black and white film, and what you need to know about it in terms of safety, handling, and disposal. This video was sponsored by the folks at thephotoshop.ie, who have partnered with me for this educational video and video series on photographic chemical safety. We'll talk more about them at the end, but for now, let's get into it. Although the opinions expressed within this video are my professional and educated opinions as someone who deals with chemical waste management as part of my job, they are just my opinions and don't constitute legal advice on behalf of myself or the folks at thephotoshop.ie. If you have a general query about Kodak Xtol or chemical disposal for home photographic use, feel free to drop a comment down below, send me an email or an Instagram DM. But for more pressing matters, you should contact your city, council or other regulatory board. As we go through the video, I'm going to give Kodak Xtol a rating out of 3 for safety, handling, disposal, and as always, cost, and then we'll tally those scores up at the end. First introduced in 1996, Kodak Xtol was the last new developer that Kodak actually brought to market. And the role of a developer is to reduce silver ions in the silver halides surrounding the exposed silver nanoparticles that make up the latent image of your exposed film to metallic silver, depositing them on the surface of those nanoparticles, growing them into the silver crystals that make up the grains in your final negative. Xtol is an extremely high-performance developer, offering a very unique mix of full film speed, very fine grain, yet still very good sharpness and acutance, excellent performance for pushing or when used at box speed, and extraordinarily high economy if you use the replenishment method. If it isn't clear already, I'm a huge fan of Xtol, and I think I'm about to rip open my 5th bag of the stuff. Like I said, Xtol is a two-part developer that comes as 2 separate bags stuck together, and regardless of how you intend to use it, you start by preparing the stock solution. The datasheet lists 1, 5 and 50 litre pack sizes, but I've never seen anything other than the 5 litre size, so I reckon that those 2 sizes were just discontinued and not removed from the datasheet. Unlike something like D76 or ID11, you don't need to use hot water to make stock Xtol, which is pretty handy. Just fully dissolve part A in about 4 litres of water to make this kind of tawny yellow solution, and then fully dissolve part B, which will clear the colour, before topping it up to make 5 litres. Traditionally, Xtol is either used directly as this stock or diluted 1:1, but a lot of people get good results using it at 1:3 or more rarely 1+2. This stock solution is a very strong solvent developer due to the very high sulfite content, which makes it an amazing option for basically any type of film, whether it's a classic cubic grain film like Ilford's FP4 or a tabular T-grain film like Kodak T-Max P3200. You're still going to get extremely fine grain and yet amazing sharpness at the same time. When you dilute Xtol, say to 1+1, you're going to see a slight increase in sharpness and apparent grain, but yet an increase in effective film speed retaining shadow detail, which makes those diluted solutions an amazing option for pushing. For those of you who print in the darkroom, Kodak say that Xtol enables you to enlarge about 10% bigger for a given apparent size of grain in the final print. So you can get a bit more cropping or just print a bit larger. But like I said in the DDX video, I do know a few people who struggle to print with Xtol negatives in the darkroom because the grain can be so fine, particularly with slow films like Delta 100 and Pan F, that it actually becomes a bit difficult to focus the enlarger. So it's going to depend a bit on your specific use case and your eyes. Starting with part A, we have sodium sulfide at 90 to 95%, basically the entire bag. Sodium sulfide acts as an antioxidant preservative. It itself is a reducing agent, and it will keep the primary developer in its reduced form or active form for longer, maintaining the shelf life of the overall stock solution. This high sulfide content also acts as a silver solvent in solution, enabling the migration of silver atoms from the edges and corners of your silver grains onto the faces, making them rounder and less jagged, less pointy, reducing the overall harshness of the grain and smoothing it out. Sodium tetraborate decahydrate at 1 to 5% is a source of an alkaline or basic accelerator, which increases the overall activity of the developer working solution. Pentasodium pentatate, or DTPA, is the bigger brother of EDTA, and it's here at 1 to 5%, and this acts as a chelating agent, binding and sequestering heavy metal ions by using its many arms to grab onto these metal ions and just not let go, trapping them so they don't interfere with the development process. We use DTPA instead of EDTA in certain formulae that are more susceptible to certain metals, or where they are susceptible to larger metals that EDTA cannot effectively bind. So that extra arm can either increase the binding strength or enable binding of something bigger. In this case, Xtol is apparently quite sensitive to iron and manganese, which are decently large ions, so the DTPA is quite effective here. And lastly, for part A, we have dimazone S at 0.1 to 1%. This is the secondary developer, and it is a more stable version of phenidone or dimazone, at least under alkaline conditions, which is very important when you're making a stock solution and storing it for a long time. And here it will also increase contrast and sharpness at very high contrast edges in the negatives by reducing this migration of silver ions that can cause a sort of a bleeding effect, reducing apparent sharpness. Moving on to part B, we have sodium sulfide at 75 to 80%, say no more, and then sodium erythorbate, or sometimes called sodium erythrobate, at 15 to 20%. This is the sodium salt of erythorbic acid, sometimes called erythrobic acid for the erythroprojection of the Fischer projection, and it's a diastereomer of ascorbic acid, or sodium ascorbate, or vitamin C. A lot of people online say that Xtol is based on vitamin C, and that isn't strictly true because erythorbic acid is a diastereomer. It has very different properties in certain conditions to ascorbic acid. It's very similar, but it's not the same, just to make that note. This is the primary developing agent which works with the dimazone S under these conditions to reduce the silver ions, growing your silver crystals. Sodium metabisulfite is a solid salt which, when dissolved, will release bisulfite and later sulfite into solution. In some sense, this will help form a bisulfite-sulfide buffer, but also it just acts as a secondary source of sulfite that might have a sort of delayed reaction over time, regenerating the sulfite content as it becomes depleted with age. I'm not 100% sure about that. So Xtol has two main developers, the erythorbate and the dimazone S, and these still form a superadditive pair, increasing the overall activity of the developer, which enables you to get away from hydroquinone and the various toxicity and environmental concerns that come with that. Stronger bases like sodium hydroxide or potassium hydroxide are also absent because the low level of borate with that extremely high sulfite content is enough to facilitate acceleration of development, even without these stronger, more corrosive bases. Like I said, the minute details of how everything in Xtol works and works together have been considered here, really making it the state of the art, at least for the mid-90s. The stock solution can be used and reused to develop up to 15 rolls of film per litre if you extend the development time to compensate for the weakening of the stock solution as you're consuming its contents. If you use Xtol 1+1, Kodak say that it's strictly one shot and should be mixed directly before use and tossed straight away afterwards. They also say that if you're diluting Xtol down, you need a minimum of 100 milliliters of the stock solution to make up your working solution. So say you were using a 1+3 solution for 35 ml film, you would have to use 100 ml plus 300 ml for a 400 ml working solution, even though that's more liquid than you need to cover a roll of 35mm film, just to make sure you have enough chemicals in there. So at 1+1, 5 liters gets you about 30 rolls of 35mm film or 20 rolls of 120 film. If you go down the route of replenishment though, which I'm not going to cover fully in this video, you can significantly increase your economy, and this is the method I use. In essence, you take 1 liter of your stock solution, set that aside as your working solution. You use it, you toss away a small portion, and from your remaining 4 liters of untainted stock, you top it back up to 1 liter. This keeps the developer near enough perfect over time, and it increases your overall economy to about 55 rolls from your first 5 liters or 70 rolls thereafter, because you keep adding fresh developer into the working solution, effectively increasing its shelf life even though it's aging. I'm still using the same 1 liter stock as I have been since 2021 with no issues. Kodak say that the shelf life of the stock solution in a full, tightly sealed container is about 6 months, or maybe 2 months in a partially sealed container. I definitely forgot to top up my can for about a year, and that stock still works absolutely fine in a side-by-side test. Nothing too scientific, but it seems to work fine. So depending on how it's stored, you can definitely go beyond that, but Xtol is still somewhat sensitive. They also say that if you use the replenishment method, the shelf life is effectively infinite, and that's honestly a cop-out, because of course, if you're throwing away a portion of the developer every time you use it and pouring in fresh developer to top it back up every time, the newest parts of the developer are never that old. So yeah, sure, I've been using the same 1 liter stock working solution for like 3 years at this stage, but most of that original 3-year-old developer, if not every molecule of it, is already gone, so it's kind of a cop-out. Xtol does have a bit of a reputation though for sudden death syndrome, if you want to Google that. And yeah, there are quite a few ways in which it can very suddenly die, whether it's oxidation, the presence of iron or manganese in particular in the water, or general allegations of poor QC from the artist formerly known as the Sino-Promise Group, who used to prepare these chemicals for Kodak. Xtol definitely had some bad batches at certain points, and it's got a bit of a tainted reputation as such, but if you get a good bag and you take care of it well, it can last you far, far longer than Kodak say. Because I'm covering part A, part B, and the working solution in this video, the safety workload for this one is basically tripled, and there's so much more information than I can reasonably take in, so I'm just going to hide and read from the script directly. Section 2 for part A notes significant toxicity via inhalation and by oral or dermal exposure, as well as the risk of reproductive toxicity. For part B, we have the same thing plus a corrosive hazard symbol. Both powders can be harmful if inhaled, swallowed, or allowed to contact your skin. Part A presents reproductive and fetal toxicity, and Part B carries a risk of serious eye damage. The working solution is much tamer, listing just, quote unquote, just reproductive toxicity and only by oral exposure. This reminds me a bit of the sodium chloride memes, even though that's not really what's happening here, and it's a good example to show the risk of a powder developer compared to a liquid concentrate. It shows you just how much the risk drops and absolutely plummets when you make up your working solution, or your stock solution in this case. Like I said last time, I'm going to show you section 4 as a reminder of the baseline safety information you need to be aware of, and only talk about the notable things. In this case, there's nothing notable beyond the minimum first aid. For section 6, as toxic as the powders themselves might be, a spill doesn't necessarily need any fancy handling. Scoop up any solids and realistically just rinse them down the drain and clean the area around the spill thoroughly. For the stock solution, you aren't going to have any vermiculite or anything like that at home, so just mop some spills up with some tissues and toss them in the bin before wiping the area down. Section 8 for both Part A and Part B mainly talks about the occupational exposure limits for the borate and the metabisulfite, which are the main risk factors respectively, and emphasizes the need for gloves, eye protection, and sufficient ventilation when handling the powder. Mixing the stock solution outdoors or with a strong air current between open doors and windows is mandatory in my opinion, and I would never normally mix up my stock solutions indoors if not for doing the B-roll for these videos. I do agree with the datasheet here, and ventilation, eye protection and gloves should all be considered mandatory when preparing the stock solution. I'd also recommend something like an N95 mask just to protect yourself from particulates in the air while you're mixing the stock up. Again, the stock solution is much more tame and just eye protection and gloves would be fine. Gloves at the absolute minimum. In this case, the SDS does actually say that ventilation isn't something you need to be concerned about for normal use of the stock solution. Looking at section 11 for part A, the borates and the dimazone S have been shown to demonstrate reproductive toxicity, and though these are a relatively small portion of the powder, there's still a lot of powder in that bag, so the absolute amount is still pretty large. Serious eye irritation and an allergic skin reaction are possibilities, and the SDS lists some risks to people with a sensitivity to sulfide or people with asthma like me. There's also a breakdown of their LD50s and the associated effects, and even treatment effectiveness for some of the ingredients, which is quite impressive. The specifics of the toxicological data can be ignored though for home use. That's not something that's relevant to us. Section 11 for Part B says that the metabisulfite is the real offender here, and serious eye damage, skin irritation, and harm from ingestion are all mentioned, along with the note for people sensitive to sulfide and some more general toxicological information that I won't go through, but you can pause if you'd like to have a look. Section 11 for the stocks gives us more general toxicological information and general notices like contains sodium tetraborate decahydrate. Yeah, we know that by now. And it's much more dilute once the stock is being prepared, and that's greatly reflected in the lack of warnings, which basically say it might be a low-level hazard if it's used properly in accordance with the manufacturer's instructions. I can't give Xtol a 3 out of 3 for safety because of the fact that it is a powder developer and because of the risks associated with the powders in the air and the strong level of PPE and ventilation you need to be mindful of. But once you prepare the stock solution, that risk absolutely collapses to almost nothing. And let's be real, 5 liters is a lot, and you're not going to be doing it quite that often. It's not like you're making up that stock solution every time you need to use Xtol. There's also the fact that there's no hydroquinone. There's no environmental toxicity warnings here, very little in the risk of reproductive toxicity, nothing about cancer. So lacking hydroquinone is a huge win for Xtol. So though I will give it a 2 out of 3 as a product, in principle the stock solution gets a firm 3 out of 3. Section 7 for each powder mentions avoiding breathing the dusts, getting them on your skin, and that kind of thing. It does note that the dust from Part A doesn't present a notable explosion risk, which realistically isn't a problem if you've ever used flour in your kitchen without exploding anyway, but it does say that Part B can present an explosion risk. I've said this before, an SDS has to cover essentially every use case and scale of operation from home use up to industrial production, and that's where the explosion risk is a concern. That's when you're talking about things like spark-proof walkie-talkies for the factory. It's not a concern for home use in that regard at all. For the stock solution, it basically tells you not to huff the fumes, along with the usual stuff. Section 10 says for both the powders and the stock solution to avoid mixing it with strong acids, and I've said this before, this doesn't really mean your stop bath. Even 30% citric acid isn't that strong. This is really talking about strong concentrated mineral acids, hydrochloric acid, nitric acid, sulfuric acid, where there is a significant risk of a large amount of heat being generated and a large volume of sulfurous toxic gases. There is a small risk of generating these gases and some heat if you were to use concentrated stop by mistake with the stock solution, but again the risk is very small and it's not something I would be particularly concerned about. Like always, I do have some practical notes based on my experience using the developer as well. The fact that you use it either stock or 1+1 by default, like with DDX I said before, makes the math super simple. How much stock do I need to use stock 500 mils? Oh yeah, 500 mils. How much LC29 do I need to use at 1+19 to make 350 mil? I don't know. You can work it out, but it's just one less thing you have to do when you're preparing to develop your film. It just makes the overall process a bit nicer and simpler. Although I have above average tap water, a lot of people online say that your tap water really does matter. In my experience it doesn't, but my tap water isn't particularly bad. And from what I've read, Xtol is very sensitive to iron and manganese specifically, probably because the erythorbate is a strong oxo ligand and it's polydentate. Forget about that, I'm rambling now. But it does mean that it's not just about how good your water is, it's about what specifically is in your water. So if you can't get good details about the mineral content of your water, it might be worth using deionized water, as a lot of people online seem to prefer doing. Although I personally use jerry cans and just top them up with butane from time to time, a very common way to store the Xtol stock solution, although annoying to fill, is wine bags, because they will collapse as the volume of the solution decreases, preventing any exposure to oxygen because there's no headspace in the bag, and that can overall preserve the stock solution for quite a lot longer and increase its shelf life quite a bit, particularly useful for people who use the replenishment method. Xtol is a wonderful developer and I do love it, but the fact that it's a powder developer and a 2-part powder developer, along with the risk of sudden death syndrome, mean I have to give it a 2 out of 3 for handling, just because it's not quite as predictable or easy to use as some other developers. Sections 12 and 13 of the SDS for Part A, Part B and the stock are basically irrelevant here. There's nothing to worry about, whether it's the powder or the stock solution or your spent dilute working solution. Down the drain, don't think about it. Easiest, quickest 3 out of 3 I've given in this series so far for disposal. A pack of Xtol to make 5 litres of stock solution costs about 18 to 22 euros at the time of recording. Let's say 20 euros. At that, when used one shot, you're getting about 20 to 30 rolls out of your 5 litres, which gives you a cost of around 60 cents per roll. When you're using it stock with replenishment or with reuse, you're going to drastically cut that cost by increasing your economy to something in the region of 20 to 30 cents per roll depending. That is extraordinarily cheap, and even on the most expensive end, it's cheaper to use than something like D76 or ID11, and on the cheap end, if you're willing to go with replenishment or time compensation, it's barely more expensive than Rodinal, and you're getting one of the highest performance developers that exists. Okay, you might prefer DDX over this. DDX is costing you an order of magnitude more per roll to develop. Now, don't get me wrong, I love DDX, but I just wanted to emphasize how cheap Xtol can be depending on how you use it. An easy 3 out of 3 for cost as well. Before I tally up the scores, I of course have to give a huge shout out and thanks to the folks at the Photoshop.ie for partnering with me for this educational video and video series on photographic chemical safety. The more videos we do together, the more people seem to come across the series and find useful little tidbits or have mind-blowing revelations about these darkroom chemicals, and just makes their lives easier, and that makes everything we do so worth it. So thanks to them for making this video series possible. Not too long ago, they completely rebuilt their search function on their website, making it easier than ever to find exactly what you're looking for, and even some related products to help you find things that they stock that you didn't even know about. Just last week, I was able to restock on Kodak's Pro Image 100, aka the GOAT from the Photoshop. It's one of my favorite stocks in 35mm for color film. Don't tell Harman. And not just the fact that I was able to get it, but able to get it for a really competitive price with such quick shipping was absolutely fantastic. So thank you again to the folks at the Photoshop.ie, and now I'll tally up the scores. Kodak Xtol gets a 2 out of 3 for safety, 2 out of 3 for handling, 3 out of 3 for disposal, and 3 out of 3 for cost, for a mind-blowing 10 out of 12 overall score. Like DDX before it in this series, Xtol is a very high-performance developer that will give you extraordinarily high-quality images. It's got a very unique formula where, like I said, everything has been factored into the most minute detail. And it does have risks associated with it, like the sudden death, but I can't personally speak to those because I'm on, I think, my 5th bag and I've never experienced it. But that's only 4 or 5 bags of Xtol out of the thousands or hundreds of thousands that are out there or have been out there. That said, when it works, and let's be clear, most of the time it does. You don't hear people posting on forums saying, oh, my Xtol didn't die, because why would they do that? You know, there's a bit of a bias there. When it works extraordinarily well, and you will get the closest thing to grain-free images that you can reasonably expect to get. One film that I think particularly shines well with Xtol is Fomapan 100, be it in 35mm format or 4x5, because that film can look a bit crusty depending on how it's developed, but I absolutely love the look in Xtol. It really brings out a wide range of tonalities. It kind of fines up the grain a little bit. It's a bit more characterful, I guess, than FP4, developed similarly, but it's a bit of a look and I really like it. I'm really glad to see that Xtol is hitting the shelves again, and I hope that this video helps you realize some things that you need to be mindful of when making or using it, or highlight some features that it has that you didn't know about, like the increase in film speed when you push, or the ability to use it with replenishment or effectively infinite shelf life of your working solution. That's all I'm going to say for this video, so stay safe and bye bye for now. If you don't already, follow me on Instagram at Shaka1277 for new pictures every day. If you liked this video and enjoy what I do on the channel, please consider subscribing or checking out my Patreon, where the tiers start at just €1 per month.